Okay, so let's try platinum. All right, what do we start off with? 1s2. Keep going. Yeah?
3p6, 4s2, 3p10, 4p6, 5s2, 4p10, 5p6.
Oh gosh, I can't keep up. I can't keep up. Oh, hang on. What was next? 6s2 and then? Good. You forgot the f's. 6. Yeah, there's a star there, right? You gotta jump down, do all of these, and then go back up. So it goes 6s2, 4f14, 5d8. Yeah, and if you would have added them up, you would have noticed you would have been off by 14, right? Exactly. All right, so there you go. Now this is a lot, right? This is a lot to write. Will I make you write all of this?
Yes.
Yeah, good guess. Yeah, but there is a shortcut, all right? So this is the longhand version of it. The shortcut version uses a little trick from algebra called a variable, all right? And you know what variables are, right? You can assign them anything, all right? Now for this, you have to assign them one of the noble gases to use the shortcut, all right? So you can pick any of these noble gases. And what your goal is to make it as short as possible. So you pick the noble gas that comes right before whatever element it is that you're looking at. So we're looking at PT. What's the noble gas that comes before it that's the closest? Xenon. All right. So xenon, it looks like 1s2, 2s2, right? All of this until we get to what? We gotta look. 2. It's gonna be a P, right? 3, 4, 5, P6. All right. So all of this top part is basically what xenon looks like, right? So this is xenon, and then you just start from there. All right. So after xenon, you go to the next one, which that was 54, so 55 is down here. So you do the cesium and barium, which is 6s2. You don't forget about 4f14, and then you go back and go up to the 5d8. And this is the shortcut version instead of having all of that. Pretty cool, right? Way shorter, yeah? And so you just start with any of the noble gases. You can use any of them, all right? You can use helium. Then it's not a shortcut, though, because writing helium is longer because you have to do the brackets and everything. That's actually longer than just writing 1s2, all right? Because that's what helium represents. But all the other ones are real shortcuts, all right? Any questions with that? No? Okay, so then let's try iron, which we just did, but with the shortcut. Okay, so iron. What is the noble gas that comes before it?
Argon.
All right, so argon. After argon, then what do we put?
4s2.
All right.
3p6.
All right, cool. So that's the shortcut for it. Now, for part of the test later on, when we're doing something called quantum numbers, we're going to need to do the orbital diagram. So I'm going to show you what that looks like now. It's a modified version of all of these arrows. So instead of drawing all the arrows on the test, we do the same thing. It's a shortcut. So we start at the noble gas that comes before it, and then we just draw them from that noble gas on. All right, it makes it a lot easier, and it helps us with that concept of quantum numbers. Okay. So for iron, we do the same thing. We put argon in brackets, but this is where it changes a little bit. Remember how we had all those boxes? Well, we don't want to waste time drawing boxes. We'll just represent a box as just a dash or a line here. So for example, S, how many boxes did S have? Do you remember? 1, right? It had 1. So we'll give S one line here, and we're gonna on the bottom call it just 4S. All right. How do you think we show that it's 4S2? Yeah, the arrows. Remember the arrows? So the rule was you put an up arrow first, and then if there's no other lines where you can distribute it, you have to double up, so then you'd put a down arrow in here. So S would just be up and down, all right? Does anybody remember how many boxes the D's had? They had 5, yeah, exactly. So same thing, you'll draw 5, and then put a 3D under it. And then do you remember how the arrows worked with this? What will we do for these 6? Good, yeah, so it's gonna be up, 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 all ups, and then 1 down on the first one, all right? And that's 3d6, okay? And with this orbital diagram, when we're doing quantum numbers later on, you're gonna wanna either circle this or draw an arrow to it, because the last one that we draw is the one we're going to actually do our quantum numbers for, all right? Even though, if you look at it to the right, this is the last one to the right, we always do, and you can do this a whole bunch of different ways. We're always gonna do it, whatever the last one that you draw is, that's the one we're gonna figure out the quantum numbers for, all right? Which is the coordinates for that electron. Where is that electron located? Okay, try iodine. Try both things for iodine. All right, what's the noble gas that comes before iodine? Okay, and then what?
5S2.
All right, 5S2, 4D10, 5P5. Good. Okay, same thing we're gonna do over here. Oh, 5P5, sorry. There we go, perfect. So we have krypton. And same thing over here, we'll have the 5S. And that'll be up, down. And then the 4D10 and the 5P5. Now, if you don't have enough room to write them all in there, you can kind of jumble it, put them on top of each other. That's fine for this, because the biggest part of this is making sure we know what the last arrow is that we draw, okay? So next up, we have our 4D. So I'm going to do it up here. 1, 2, 3, 4, 5. And it's 10, right? So all ups and then all downs. 4D, good. And then we have the 5P5. 5P, up, 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 down, and then down. The last one is in the center, aimed down, right?